Hi guys, welcome back to Solidity Basics. In this section, we'll be covering arrays. Arrays are a sequence of data. So you have some kind of data type and you have a sequence of values corresponding to that data type. They can be of dynamic size or a compile time fixed size. So pretty much similar to how you have used arrays in other languages. You declare it by writing a statement like this. Here you are saying that the array doesn't have any fixed size and it is of type uint256. In the second line, you are declaring a fixed size array and initializing it as well. So you have an array of size 3 initialized to values 1, 2, and 3. And then here you are declaring a fixed size array, and since you are not initializing any values, all of the elements are initialized to the default value of that data type. So we have uint256 as the data type, so all of the values are initialized to 0. Then we have some functions that help us in getting the values out of array, adding them to it, deleting them from them. In the first function, we have a function called get, where we'll get the value corresponding to the ith index in the array. So let's say if we have this array, the index values are 0, 1, and 2. And if we pass in 2 here, so we'll get the value 3 from our array. This function returns the entire array. The return type is set as uint256 array. So we get the entire array in return. In this function push, we add a value I to the end of the array. This basically appends a new value to the array. So if we do a push on this array with the value 4, we'll have 1, 2, 3, and 4 as the new array. In pop, we remove the last element of the array. So if we do a pop on this array, we'll get the resultant array as 1 and 2. Get length returns the length of array. So these are basically the properties of the array: push, pop, and length, associated properties and methods of the array. So with the length property, we can get the length of the array. Array dot length would return us 2 for this kind of array. If we delete the value at a particular index of the array, it doesn't change the length of an array, unlike pop, which removes the last element of the array and changes the array length to n minus 1. If we delete a value, the value is simply reset to the default value of the respective data type. So we have the data type as uint256 and the default value would be reset to 0. In the following two contracts, we discuss the ways we can remove a value from an array. So one way is to remove by shifting. Let's say if you want to remove a value from the middle of an array, you copy the values that are ahead it one by one, shift them one by one, and then pop out the last value. So let's say you have an array 1, 2, 3, and you want to remove the value at the first index, that is 2. You copy the values ahead by one step. So 3 would be copied here, and then you pop out the last value. So the result would something like this. After copying, you would have 1, 3, and 3. And then when you pop the last value, you have 1 and 3. If you take a bigger example, let's say 1, 2, 3, 4, 5, and 6, and you remove the value at the second index, which is 3, you'll copy 4 at 3's place, then 5 at 4's place, and then 6 at 5's place. You'll get something like 1, 2, 4, 5, 6, 6. And when you'll pop out the last value, you'll get the final result, that is 1, 2, 4, 5, 6. The logic here is written according to that, and you might notice that we are doing multiple operations here, and when we'll execute these operations on the EVM, each operation would have its own gas cost. So we have another way to remove a value from the array, but the caveat here is that the sequence of array would get altered. So this method would save you some gas cost, but again it will come at the cost of altering the sequence of array. So you can evaluate the trade-offs and choose the method that works best for you. In this method, we copy the last element to the place where we want to remove the value and then we pop it out. So let's take the example that we had taken earlier. Let's say we have an array 1, 2, 3, 4, 5, 6, and we want to remove the value at the second index, which is 3. Now, if we do it by shifting, we'll shift 4 here, 5 here, 6 here, and then pop out the 6th value. So we are doing multiple operations. We can directly copy the value 6 at 3's place and then pop it out as well. So it would save some operations of shifting the values ahead by 1. And the result would be an array which has values 1, 2, 6, 4, and 5. So we have the order changed here, but in the shifting method, we have the order intact. Cool. So now we'll check it out on Remix ID. I have the first contract loaded here, which demonstrates the basic array. We'll compile the contract and then we'll deploy it. So we have an array stored here. Let's try adding some values to it. I'll add 5, I'll add 10, 15, and 20. So we have added some values in our array. If we do get array, we get the entire array 5, 10, 15, 20. If we do get length, we get the length 4. If I do pop and then do get array, we see that 20 was popped out and the length was changed to 3. And if I remove the value at the first index, which is 10, let's say if I remove it and then I get the array, it's reset to the default value, but the length of array didn't change. So next we'll see the contracts that demonstrate removing a value by shifting or removing a value by overwriting. I have modified the contracts slightly, so you can check out the contracts on the website and you can go through the logic. Here I'll demonstrate the difference it will create in execution. So let's say if I compile and deploy this contract and I'll simply run test here. So we see that in testing we have the execution cost as this value, which is this. So we'll keep a record of it here. In the shifting method we have the gas cost as this value, but let's say if we use the swapping method and then we run it, so now our execution gas cost is this. So this was a very simple array where we had 8 values, but when you extend this logic to an array which has a lot of values, you'll see a massive difference in the amount of gas being used for the same logic. So you can choose whatever method that works for you. Both have their own trade-offs. Cool. I'll see you guys in the next video.